World, we are back and we are rendering vertices and color and beauty. Look at how beautiful that is. All right, so in this episode, I just want to go over a restructuring of our file system. Right now we have a renderer and a shader class, and that's about it. We have our view. We're not working with that yet, but we have a renderer and a shader. Shader looks fine. That looks great. This renderer is ridiculous. Renderers shouldn't hold vertices or indices ever. That's a rule. I don't know if that's written down anywhere, but it should be. So we're gonna get rid of those, and we're also gonna get rid of these constants because we don't actually need them anymore. I'm gonna do that right now. So we're gonna get rid of these constants. First things first, I'll put this delta time in the future. I'll do it again. And then so we got to get rid of this constants right here. And yeah, so now we're just setting the vertex data, and then we're drawing the index primitives. So let's break this out. I'm gonna open up something that I found on whatwhenhow.com. And it has to do with scene graphs. And so when we set up our project, we just basically have a renderer. And instead, what we're going to set up today is we're going to set up this scene graph. And what a scene graph is we have the basic, the root node called the head right here. It's the world. And then we have sub-objects underneath it. So if you call these each nodes of a tree, if you know data structures, or if you've taken an algorithms course, you'll probably know that this looks like a tree because it is. And each little circle here represents a node, and the node can represent either a group of objects or an object. So I guess in the case, if we're doing some sort of a game or a movie, let's just go game. I'm turning to game right now because everybody loves games, and games are actually kind of fun to make. So if you look at this world right here and pretend this is the scene, and don't even pretend this is a scene. This is like this is granddaddy right here. This is the base class. This is what renders a scene. This is the renderer. Let's call the world the renderer. It's not going to be the renderer will not be a node, but it will be because we can have a group of scenes. Anyway, let's just say it's the scene for now. So the scene has a bunch of stuff underneath it. So say it has a triangle, basic object. And then it has a guy. This is a guy. This group right here is a guy. This represents a guy. And then he has a left arm, which has an elbow and a hand. And then he has then he has a leg that doesn't have anything. He's a weird looking guy. Laugh at your own jokes. Okay, so that's kind of how this is represented. If we want to render this or rotate this little world, we can, or we can rotate the entire world. So I'll go into it a little bit more. This is how we're going to set it up. So the first thing we need to do is create a node class to create for the tree. And let's do that. So I'm going to open this. I'm going to create a new group because we're going to have a bunch of different kinds of nodes, and I'm going to name it node. And in node, I'm going to put a new file, a new Swift file called node. Yep. Oh, it's still making these. All right, we're going to go clear those out, I think. Let me go to this real quick. Okay, so if you want to clear that out, I reset my computer recently, back to scratch. So we're going to show package contents, library spotlight maybe. Nope, I'm going the wrong direction. I'm used to it being like this. Developer. Then we go to library. Then we go to Xcode. Then we go to templates. Then we go to file templates. And then we go to source. And then we go to Swift files right here. This is what I want. I need to get info, change the permissions on this guy. To read and write. Save that. Close U. go here, do the same thing with you. I just do not want to do that anymore. I'm getting sick of it. And also, I'm doing a lot of metal stuff, so this will come in handy. So we'll go right there. This is read only as well. I'm gonna change that. And read and write, lock, boom, open with, just need text edit. So, so the file name, node.swift, that's cool, project name. I don't know how to get the class. So, file maybe? I'm just gonna go like this, import, because we might want to do structs too. Why did that do that? That was weird. Import metal kit and get rid of all that stuff at the top. I'm gonna save that, put you back, go right here, and I'm just gonna test it. So I'm gonna delete this guy. We're gonna make a new node class called node and just make sure that import metal kit. All right, cool. So now we have a class node. So you got rid of all that stuff before. It's awesome. So now I have a class node, and just like in this picture, we're gonna create children for these nodes. Okay, so so var children. Could probably be a let, but I'm going to do a var, which is going to be an array of nodes equals that, empty array. I don't know why I'm doing that. And then we're going to want to add, so we're going to make a simple function called add that takes in a child node. And that will be a node, and it will add, it will append to the children. Children.append child. Okay, cool. So that's it. Now we have this little structure and we can add to it, and through recursion we can render all the subgroups of this one. So this is called a scene graph. So it's more of a scene tree. If you think about it, I don't know, it's called a scene graph. Yeah, scene graph could also be to organize visual attributes found in. Yeah, why is it called a graph? I don't know. Someone else might know why it's called a graph instead of a tree. It looks more like a tree. It is a tree. I don't know. Scene tree, scene graph, whatever. That was kind of gross. That was a piece of ice. All right. So now that we have a node, we can create some scenes. So we want a scene to hold all of these different guys, right? So if we have a scene with in Call of Duty where we want some box on the left, and then we want like a tank, and then we want like some random object here, we do that with here. So let's do that. Let's create the scene. So I'm going to create a new group called scene, and then this scene will be the base class for all the other scenes. So we can have multiple scenes on a screen. You can have HUDs, heads up display, so that it doesn't move but the world moves. And that's just kind of a way to, so this will be a scene. Give me a super class. I don't need that. That's kind of cool. All right, and then so this will be our basic scene, and our scene will be a node. Just like I said. So we'll have a bunch of children underneath it that we won't need to worry about. And yeah, so for the first node, for the first thing we're going to add to this scene, which will be initialized, well, with a device. MTL device, because there's things we'll need to do on this side. Yeah. I think we'll need to initialize it. I'm gonna do that. I'm just gonna wait until we do need to initialize it with that. So we want to make a. So right now we're doing this. This is our plane. That's cool. But it's just nothing. It doesn't mean anything. It's not an object. We want to put it in an object of node, a node type object, so that it'll do it itself. So let's go over here, go new file, make this new file called plane, and yeah, basically everything from the renderer is going to now be in the plane. That isn't, like, the renderer is supposed to render. We know this. So let's make it render and make the scene do all the work for the sub-objects, and the sub-objects make sub-objects do the work, and et cetera, et cetera. So let's go to let's do this. Let's go scene, and then we're going to click this guy. And then if this doesn't come up, remember you can go up here and kind of navigate to renderer, because that's what this class is. So now that we have our renderer up, let's take some stuff. So we don't want our renderer building vertices or building buffers. No, that's not something we want our renderer to do, so we're going to do that on the scene side. No, we're not even going to do that on the scene side. We're going to do that on the plane side. That's what I meant. And then the plane is a node. Yeah, we're going to do that on the plane side. So our plane will build vertices, our plane will build buffers, because this belongs only to the plane. These vertices are only to the plane right now. So we're going to apply those on the plane. The next thing we're going to do, so we don't need this stuff. Next thing we need is we need our vertices, indices, and vertex. This stuff right here. Right there. So now we have our vertex buffer and our vertices and indices on this side. Sweet. Okay, so these errors should go away. Man, I'm thirsty. Sorry. Might need to go fill that up in a second. I just ran. Yep, so vertices, so, yeah, okay. So now that we have a vertices and indices on our plane, doing exactly what we want. You see how this is using device? It's not blowing up or anything, but maybe yours is. We need a device on this. So we need to initialize it with a device. And then we can say build buffers with our device. But it's gonna complain at us for now. We need to go super.init. Just initialize our upper class, and now we have build buffers. Check that out. Then we have vertices. I think this should actually render, or should not render, but should build just fine. I'm gonna build it. Building can't stop me. Just want to see. We're not doing stuff on this side, so take your time, Xcode. Oh, okay, so we're getting a little error, and this is the easiest way to kind of clear off this stuff. Oh, well, yeah, we can't do this because the vertex buffer's on the other side on the plane now, so we need to take from the plane. We need to take from here. These two gentlemen, and put them in their own render. So func render. Yeah, so there's something else we need to do right now. Gonna have to jump back to it. Gonna make these look a little nicer. Yeah. So what the hell's a command encoder? We need to tell it what a command encoder is. We'll just pass that. Render command encoder. Is it getting dark in here? I'm gonna open up. Ow! Whoa. Now I probably look super pasty, but it got dark in here. So luckily the window's right there. Yep. So now we're setting our vertex buffer right there. That looks good. That looks good. That looks good. Now on this side, we can just, instead of doing all the vertices, we can say, well, we need to do one more thing. Sorry. Getting ahead of myself. The scene class. What the hell is this scene supposed to do? Like we got to be able to make a scene. I need to be able to call scene, and then say self.scene equals scene right there. See that? So that the scene does the rendering, not the renderer. So I can call down here. That'll probably go away. If it doesn't, we'll figure it out. Scene.render. And then, well, since scene should be a node, our node needs a render. One more. Render. And what that will do is it will go through all of its children and render. So it'll go for child and children for each type deal. Child.render. And we'll need to take in the command encoder because through each step of the way, we're going to keep adding things to the command encoder. Render, and then we'll need to pass in the command encoder right here. And there is your recursion. Recursion. It's basic recursion, not too complex. But yeah, we're using recursion to render all of our children underneath. So here I can just call scene.render, pass the command encoder. Right there. And so there, we got rid of all the rendering. We're going to let the scene do all the work. We'll worry about this pipeline state in just a second. Oh, because this is not. Solve that. Okay. Yeah, we're going to get rid of this render pipeline state in a second too, because that doesn't need to be on here because we can apply. But all right, so now it should be as easy. Oh man, I love this scene graph tree. We can just do an initializer here with the device, mtl device, and we can say stuff like add plane type deal. Well, child plane. Look at that. Look at how easy that is. Does our plane need anything? Needs a device. Well, it's a good thing we're passing in that device. So device. Why not? So now we can just add the child to the plane. The plane will do its own stuff. We also need to build buffers. Before that, we need to build our vertices. If we don't have any vertice data to put into our buffers, this render will be an override. I'll just push this button. So yeah. So now that we have scene.render and our scene's already being generated right here with our device, I think we are ready to press play. We've already got a few objects underneath. Oh. Missing buffer binding. Okay, well, we know what that is. Okay, so missing buffer binding at index 1 for constants. Well, we got rid of our constants. So our shader is like, dude, you said, no, you lied to me, dude. You lied, bro. Bro. Well, now we have all this jargon. We gotta get rid of that stuff. No constants, no constants. Now let's build. Everybody's happy. So happy. Look at that. There's our plane again. We're rendering it. We have size, which we're going to take out also. So this shouldn't be size anymore since we're going to be doing it around 1. Let's just do 1, 1, 1. Just eliminate this size nonsense. And we'll scale in the future. We won't just put size. So that'll put it back to 1. That'll fill up the whole entire thing. And while we're at it, let's make something a little more simple. Well, no, I'm going to keep this plain because there's a lot more stuff we can remove from here. A plane, how do I say this? A plane is one type of object. So our plane is going to be basic. It's not going to be a textured plane. We'll make a textured plane or a plane. And so this plane will have color of just whatever colors we attach to it. We're not going to put any textures on this one plane. So we can call it primitive. It'll be the most basic. It will use the basic vertex function and the basic fragment function. For something that's textured, we'll want to make like a textured function and a textured fragment. So we're going to make what's known as a primitive class. Okay, so primitive will be a subclass of node. And you'll kind of understand once I get into it, hopefully, what the hell I'm talking about. And we have that class, primitive. Okay, and this primitive is basically going to take this render pipeline state and put it here, because the primitive will use this one render pipeline state. Maybe a textured element will use another render pipeline state, and so on and so forth. So right here we'll put render pipeline state. Look at that. Now we're down to 2 objects in the renderer. And we're about to remove so the command Q can stay. I'm just gonna put it up in this top function just to get rid of it. We create the command Q once, not twice. First thing you do is commute. Okay, and now this is complaining, so we need to put this whole entire guy over in our primitive. And our primitive, will inherit node. Right, so that's good. And boom. See, so command encoder.send render pipeline state. Yeah, we don't want that to happen, so we're gonna need to just go and put this in a render over here. So our primitive won't have a render, will it? Yeah, it will. So we're gonna put a render on this. Func render command encoder mtl render command encoder. And first thing we're gonna do is do this. This will be an override. And then we're gonna call super.render command encoder. Okay. Render all the primitive subchildren. So there we go. Now we have the pipeline state being built specifically for this one. I mean, if you're setting the vertex descriptors for this one type of function, right? You're not setting it for a different type. We're going to create multiple. We'll create like a texturable or something like that, and then so that's cool. So we don't need this build pipeline state. Look at how much it's going away. It's so basic. All right, so now we're passing our command encoder to our scene. Our scene's doing all our work. We have this primitive that inherits node. Now our plane can inherit primitive. And if I go over here and I put my primitive, well, no. If I go to my primitive and then put my plane right here, I'm going to take from it. So primitives will have vertices and indices. Easy. Primitives will have everything that this guy has, basically. The initializer will be, well, we can put the initializer in here because this will initialize the exact same way. Yeah. So init device. So I'll just take that device. I'll just take this initializer because we'll do exactly the same thing. Since this will be a primitive, once we say init, it will do that. So build vertices. Well, we need build vertices. So this will be a func build vertices. Don't do anything there. Probably make this a prototype. This would be override. Build vertices, so that'll just do that. Then, so that looks good. Now build buffers. This will be the exact same for every primitive. Takes in the device. Beautiful. The render. Will this be different? Vertex buffer. Draw index primitives. Easy. Take you. Put you in here. And, well, we already have a render, I think. Yep. So we're just going to do all this after we call super.render. Render all our children and then do that. So now look at our plane. Look at how easy it is to make a freaking primitive. So we go here, here, here. You got an error. Where are you? Plane device. Oh. Yeah, you're good. Okay. So now, since my scene only has... Yeah, that's it. Okay, let's press play. Let's see what happens. I don't know if it's going to break. Uh-oh. What? What are you talking about? Build vertices, build buffers. Okay. We're not getting to this render pipeline state. We're not building our pipeline state. Oh, it's probably because we don't call it, huh? There we go. Let's try that. So, yeah, it looks like our code's just spread around now. I understand that. But I'll show you why this works so much better. Because now, let's go back. Let's just look at all the things that we just did. We created a lot of classes just now. All right, so our renderer, rendering the scene. In fact, I'm gonna do it. I'm gonna go here, new file. We're gonna create a couple more files before we do this. So this is gonna be basic scene. This is what we're kind of gonna be testing in, I guess. Create. Yes. You will be a class. You will be called basic scene, and you will inherit scene. You get all the goodies that the scene gets. I'm gonna get rid of this out of the scene. I'm gonna go var device, mtl device. Just like so. So now our basic scene doesn't need to have an initializer. It can do whatever the hell it wants. We're going to make an initializer though. And what that's going to do is go super.init. We need to take in the device every single time now, but that's okay. It's all right. So now we'll have this scene, super.init device, and then, so for the basic scene, override init, right, I got it, right. We can say add plain device, mtl device, and then we're gonna make another scene. No, yeah, so I mean I'll do the basic scene. I just want to make sure this works. Let me go to render. Let me say equals basic scene. Oh, inheritance. Build failed. What are you talking about? Oh geez. Swift, you and your pickiness. MTL device? What do you mean that's not a device? It says device in it, just human logic. Be nice if we could just call human logic. Not just use the same shit. Boom, there you go. So we're rendering that. We have our basic scene. Now we can create another scene called, I'm gonna delete this in just a second. I just wanna prove a point. Temp scene. Oh, what the hell? It's not a function. We out here trying to function. Ugh. Let's see, 40. Okay, I'm not gonna add a plane again. I'm gonna create another one called triangle. So new file called triangle. I'm gonna take this primitive or this plane, put him in triangle, and we're just gonna redo the triangle again. Just the 3 vertices. So now, oh, that's color. Who didn't tell me about that? How dare you? How dare all of you? So now we have our triangle. In my temp scene, I'm going to add a triangle. Remember, we got to inherit our scene. I'm just going to say, what the hell are you talking about, dude? You're on crack. And over here in our renderer, we're going to call our scene. We're going to create an array of scenes. So var scenes, plural, is an array of scene equals empty array. Nice. Don't need that. Now we can just say scenes dot append, just like so. And I guess we could make the renderer a freaking node. I'm not going to do that though, because we could have we could just have a top class called world, and the world has scenes. Oh, I should just do that. Should do that. No, not yet. It's too much work. I kind of want to. That would make more sense, wouldn't it? I'll just follow through. Let's be a temp scene. And then for each scene, no, this is in vb.net, for scene and scenes, just take this guy. And now we should get, well, we have basic scene, which is a plane, temp scene, which is a triangle. And so we get a plane and a triangle, but they're like on the same. So, what is that? That's some... I'm not going to comment. I'm just going to ignore that for now. That might fix itself. I don't know what it is. It could be that it's all at 0 and it's trying to render each scene together. Sometimes that happens when there's weird data coming through, but I think we're okay. I go into my types and just remove this constant so I know that that's good. Huh, I've never seen that. I'm just going to ignore it if that's okay with you. Just ignore it. Yeah, okay. So behind we have one scene, and in front we have the other scene. Interesting. Okay, so yeah, but I mean, that'll probably be a world thing. I'm just going to create one scene from now. For now, just because I want to. So I'm going to go back. I'm just going to go Control Z. And then our scene's going to render. And we'll have one scene. That way we don't have to worry about whatever the hell that was. I don't know what that was. I'll have to look it up. So now we don't have rendering, so that's cool. Did I change something? Scene.render, scene equals basic scene. There we go. Okay, after this, I'm going to pause the video and go get some water because I am really, really thirsty. I might even open a window. Yep, so there's our plane. I'm pausing. Can't stop me. I'll be back. Okay, so we've got our scene. We can add to it. That's nice. What next? We could go over constants and math. We can apply math. I would have to go and get my little math book. I think I actually have it right here. Yeah, how does this work? All right, so let's do that. Let's apply some maths. All right, so I'm gonna have to first describe what the hell is going on. Let me see what time I'm at. We have a half hour. So let's apply some math. Let's just do like at least basic scaling. We can do rotation in another video, or I could just like pause it and apply it and then walk through it. That one's kind of a weird. That would take a little time to type out. But Yeah, so we're gonna need a math class. I'm not the best person to go over math. And I actually haven't even thought about this before this video. So we want to add depth to our scene. We want to be able to render in whatever hell order we want. So let's try to draw some stuff. I'm gonna try to invest in like a cool little pen in the next few days, but not now, and I want to get this out. So if we open up Patina right here, and we go, so say I want to draw a square, right? Actually, I'm going to draw it filled. So say I want to draw this, right? And then say I want to draw, oh my god, give me a fill zone. This. Or, well, there's a good way of doing that. So say this is the screen. And we want to rotate this 90 degrees. And we have two, I saw this in a video one time, so I'm doing it. So say we have these two triangles, right? And we know that this one we want to render in front of this one, but we drew this one first. So in the order right now, if you were to draw, it just kind of puts everything at 0. So the first thing that was rendered was this. So this was number 1. We added this triangle, and then we went on and we added this triangle, right? And I guess, so let's imitate this. Yes, that's what I'm gonna do. I'm gonna imitate this so we can kind of go through the process. That's a good idea. All right. So we have the first triangle and the second triangle. And then, so I'm gonna put, this is just gonna be whatever color I pass into it. Let's get set up. So I'm gonna add 2 triangles. Let's make our triangle a little bit more easy to change its color. So in it, we'll pass in the color. Which is going to be float 4. And then we're just gonna make the whole triangle that color. Why did I give it a ray? And so we're gonna have to call super.init device and device. I'll have to learn how to spell. I think I have basic English tomorrow. I don't know what I'm saying. I'm just saying things. Okay, so we're gonna need to take in the device. Okay, so we're going to take in the device and then a color. So the color will be all the same for this triangle, just for the sake of saking. Oh, what am I doing? I think I can do it this way, right? Can't I just go like this? And go color. If you hold Alt and you select multiple things, you can do what I just did. So now we're gonna have one triangle of one color. It's gonna complain to me over here in our scene, basic scene. I'm gonna add this because no, it's not gonna. And then we can't rotate it yet. I can still draw it. This might be too hard. It might just be too much work. We're gonna do it anyway. Okay, let's just make sure this guy works. So the problem is I'm drawing him. Oh. Extra argument. Float 4. Oh, this should be color. Right? What are you talking about? What are you doing? Okay, whatever. float 4, and this will just be, wow, you are really slow, computer. This video software rendering is beating up on my computer. Okay. That should do it. Everybody should be happy. Oh, how dare you. Oh, good. So build vertices. I'll go var color float 4 self.color equals color. Now it'll work. Everybody's happy. Oh, we don't add that. We make the triangle. God, what a, oh my goodness. Basic scene, where are you, triangle? Triangle, right there. Right there is where we do color. Yes. That should do it, right? Everybody's happy? Please, senor. They'll succeeded. It should just be a red triangle. What is that? Okay, I've got to evaluate it. It looks kind of cool, but it's not what we want. That's bad. So we have this taking a position of 1. V in color. Color is a float 4. We know this. So let's go back to our render, or let's go to our primitive. It could be from our primitive, to be honest. And then we have our triangle indices.count offset 0. Float 4, float 3, buffer offset, float 3. That's good. So let's do a little bit of freaking evaluation. I was chosen for, oh, do you think? I've seen this before. You can take in a float 4 position. Change that. See what happens. Oh, I see. You're too cool for school, aren't you? I'll do this myself. Let's see here. I am highly confused. It looks like some interpolation. Something's messing up on the rasterizer. Take this in as a const. Is it changing something? Yeah, it's definitely the rasterizer. It's because it's. Oh, I think I know what it is. I'm gonna go back. Take in a float 3, just like so. Then I'm going to go over to my triangle, and I'm drawing a million freaking indices. That's why. I have 3 vertices, and I'm drawing way too many. There it is. Beautiful. Okay. Trying to think of the best way to do this without being too monotonous. What the hell? Okay, so I'm gonna have to pass in vertices. So we have a color and vertices. So I'm gonna say, and this is going to be a vertex array. Yeah, that's not so bad. So var vertices. Since we can't do any rotations yet, and I just want to prove a point, let's add rotation. This is way too much freaking work. All right, so we're gonna need rotation. I'm gonna put some rotation on here. That's what I'm gonna do. So we're gonna go to our, we're gonna create a new group called maths. And then we're gonna create, I say maths because I watched a bunch of British videos and they all say maths. So now I say maths. And we're gonna go maths. And this won't be a struct or a class. We won't even look at it though. Okay, so the first thing we're gonna wanna do with this freaking triangle, this beautiful red triangle that we've drawn, is scale it. I wanna shrink it, okay? And if we go over here onto the Google machine and we just type in, we're about to get into some matrix math. If you don't know matrix math, just find some tutorials on matrix math and graphics, and I might run through some of it in a second, but not all of it. All right, so basically what matrix multiplication does, it allows us to multiply one thing by another thing by another thing and get a whole nother product just by multiplying those three together. So we're gonna have this, we're gonna we'll wanna scale it, rotate it, translate it, and this is the model. We're gonna do that with the model. And then for this, yes, we want to rotate the model. So the triangle is the model. So keep that in mind. So matrix scale formula, and this one's actually really easy. If I go to images, this is like the easiest one of all of them. And just find what we're gonna do. See right here. This is it. This is how you scale. Right there. So that's the formula I'm gonna write. I'm gonna do that right now. First thing I'm gonna do is I'm gonna go extension of a float 4x4 because that's a matrix. What this is gonna, so we can write functions for the float 4x4, and I'm gonna call this one func scale. And then we're gonna scale it on axes. So if it's, let's go to our pattern. Let's do scale first. So I'm gonna go new. So if I have this guy, and so I want to scale in the y, right, or in the x. Sorry, this is the x. So x scaling. This will be the y scaling. See that? And then if it's a three-dimensional object, it has a z, but we don't have a three-dimensional. We have just x and y scaling. And then if we can like put those both together and scale it. The reason scale exists in computer graphics is, say I have I don't know, this Raspberry Pi, right? I had this Raspberry Pi, and I made this Raspberry Pi in some modeling software like Blender, and you would put all these things and scale to what they are, but you would then make me. You would make a model of me, and then you'd put us side by side, and in the Blender project we could be the exact same size, right? You can have this giant old-fashioned looking computer right next to me, or you can scale it down so it can fit in my hand and I can hold on to it. So that's the idea of why scaling exists. It puts it into perspective of how big, like relative to me, what it would be. So that's that. So let's apply scaling. Enough talk. So scale, we're going to do that on an axis. So axis, which will be a float 3, x, y, z. And then we just write this formula. So this is going to be a mutating function because I'm going to mutate myself. I'm gonna mutate this float by 4x4, but I am going to create var result. So I'm going to create what we're multiplying ourselves by. So var result equals matrix 4x4. Wait, matrix identity. So we're just going to instantiate an identity matrix, which is basically multiplying a matrix by 1. So it's like 1. It's the equivalent of we're making a 1 matrix. And then we're going to say result.columns equals, and then we can just set our columns right here. So I can say like float 4, 1, copy that, since our columns of a float by 4 are float 4 by 4, we can do it like that. So keep in mind this is columns. So yeah, if we go to this guy and we look at a matrix, we're doing it by columns. So I'm gonna say I'm doing a matrix. I'm gonna do this a cheat way. Here's my matrix, and I'm going to do that. I'm going to do, yeah. So here's our matrix, and we're going to put 1, 1, 1, 1, 0. So our identity matrix. Really, if you haven't done linear algebra, that would be the time. So we have our, so we're talking about columns. So this is a column. Yeah, I'm going to do this just a little bit nicer because I can with this. Oh. Column. And this is a column. So columns, so this is the 3 by 3 matrix. Since I didn't do a 4 by 4, which I'm going to do. I am so sorry about this. I am so slow. I just want to drive it home. This is really good, by the way, this drawing with the mouse. If you haven't tried it, you'd probably be better than I am. There we go. There's our float 4 by 4 matrix. I'm going to just take this guy, move him just a little bit. Right there. So we have our float 4 by 4 matrix, and we have our columns, like I showed. I wonder if there's like a different dashed line I can use. This looks ridiculous, like a bunch of balls. So we have those columns, right? So column X, Y, Z, W. So this one will be not a 1. This is going to be what we're multiplying by. So axis.x, this will be x, this will be y, and this right here will be z. See that? And then that's it. 1 stays 1. So this is homogeneous coordinates. I'm not going to get into it because there's plenty of other resources. I might even put some in the description, but there's a lot of resources. So result.column, what's going on here? Columns. Is that right? Yeah, so result.column. So we're basically going to do this, what I did here, right here. So I'm going to make that small, and I'll just show you. That is what I'm doing. Okay, so we want x right here. So I'm gonna go let x float, make sure it's a float, equals axis dot x, right? And I'll do it for the y and for the z. All right, so columns. We're gonna go 1, 1, 1, 1. Why not? No, we're gonna go 0, 0, 0, 0, 0. I'm gonna take you guys, put them right here. Yes. Now this will be 1, simple. And this will be, well, x, y, z. See, so, but this is columns, so we gotta basically, what's the term? We have to T-word, what is it? Take the, I can't remember. It's like where you go M to the T. I you need to review your matrix math. That's all you've been doing. All right, so that's it. There's our result. We just want to return self dot self equals self, no, matrix multiply, whatever we are, self times the result. See, simple enough. And so we have row 1, column 1. Well, here's column 1, here's row 1, row 2, column 2, this is column 2 and row 2. See, so I mean it kind of lines up exactly the same. What are you doing? Do I have to go? What are you doing? Float 4. What are you talking about? Result self dot. Oh god, this is not float by 4. This is a matrix float 4 by 4. Embarrassing. Okay, so now we can scale. So now that we have this, let's just take this and run with it. Okay, so now we have this one method called scale. And so when we run, let's just run to see what we have right now. So we have this triangle centered at 0, 0, right? So let's go and remember how we passed constants in to the renderer, to our vertex, and to here? We're going to do the same thing, except now, instead of just constants with an animate by, we're going to create what's known as the model matrix. Model matrix. Right? And this is actually the view matrix. Not model matrix. Well, no, model constants. Sorry. And then the model constants will have a float. See, here's where it's float 4 by 4. You don't need to put matrix. And then this will be the model matrix. See that? So now we're going to take in this model matrix and we'll do exactly what we did before, where we do this and we say model constants, take in the reference, and so it'll be less than 4 kilobytes, model constants, and this will be at buffer 1. See that? So now we'll take in our model constants and we'll do work on them. So the way it works, since we have a float 4 here, we can multiply this float 4. So here's a float 3. We're going to multiply our matrix, our model matrix, by our float matrix, like so in this case, we have a float 4, right? So we have a vertice. This is a float 3. So pretend this is a float 4, just for our sake. So here, this is our float 3, and this is our float 3. We're going to multiply our scale times our vector, our vertex, okay? Just like it does in this image. And so it's as easy as saying model constants times that. Model constants dot model matrix, right? Yes. And the model matrix will be the scaled matrix. We won't actually, the vertices will never change. The vertex stuff will never change. Only this model matrix will change, okay? And so if I go back to the model, which is our triangle, see that? Actually, we could do it in primitive because primitive is where should I do it? Triangle. Yeah, I'll do it in the initializer. So if I go to primitive, I can do it in triangle. Why would I do that? I could even do it in node, to be honest. No, I'm going to do it in, it should be a renderer, but primitive. We're going to put it in primitive. So primitive will have a var model constants, and we haven't created that yet, so we need to go to our types, and we need to create the model constant struct. model constants. And then we'll do model var model matrix equals matrix identity flow 4x4. So we're just going to create a model matrix right there. Boom. So now in our primitive, we can just say, instead of this, we can just go equals model constants like we did before. Cool. Now with our model constants in place, right before we do our rendering, we will do stuff to this model constants. So in our triangle class, we want to scale, right? So we can go model constants dot model matrix dot scale, right? And then we can scale it by a float 3, and we'll just pass in 0.5. So it should fill up half the screen. And if I run it, we're going to fail. Buffer is only valid on constant address spaces. Constant. I forgot about that. We didn't bind the vertex. Set vertex bytes. So command encoder dot set vertex bytes. Not well, set bytes, I think. Bytes. Yes. The hell? Set vertex bytes. And we're going to pass in the reference to model constants. Memory layout of model constants dot stride at 1. Put that at 1. Whew. Now let's try it. And let's see if this triangle really scales. Oh, look at that. We scaled it. We freaking scaled it, man. There's some fun stuff we can do. Yeah, there's some pretty cool stuff we can do. Where we now, yeah. So see, we're scaling this matrix. So let's just say triangle. So primitive. Let's say func scale. And then I'm going to go and take this from here. Oh, that's not what I'm going to take. I'm going to go to the triangle. Put this in primitive. And then we'll have to have like some sort of a renderable class that will do this for us, but I'm going to just keep throwing it in primitive because it's easy that way. So we're going to scale out inside here. So our triangle won't actually even have it. It will be a member of the primitive. So from our scene, basic scene, I can go instead of, so I can say var or let, let's do var triangle, and then that'll be the triangle that we make. It's going to complain. It's okay. Command V. So we're going to add this triangle there, and then so we're going to say triangle dot scale, and then we'll say float 3 1, right? Yeah, and this should be let. I knew it. I knew it. So we should get the exact same thing that we got before, but this time Yep. So we can do that now. I'm gonna say this is triangle 1. This would be triangle 1. Add triangle 1. Now let's do that with another triangle and see if we can scale him separately. Yeah, we're doing math, guys. We're doing math. It's not too complex. It's fairly easy, to be honest. Once you get the hang of it, it's easy at least. And then we go right here. So we're gonna add 2 triangles, triangle 1, triangle 2. They're gonna be right over each other, right? Ah, okay, so you can't see it. That's okay. That's okay. Never fear. Never fear, because we're not gonna scale this one by 0.5. We're gonna scale it by 0.8. So it won't be touching the edge, but it will be touching the, oh, and it's not green. We wanna make it a different color. It's just gonna appear inside of it. Oh, giant, right, that makes no sense. Can't. We're gonna make it a different color. Remember, we're rendering order is important now, because like realistically this one should go first. So I'm gonna actually make this one 0.8, 0.5, and there's no way for me to control that except for rendering them in order right now. And that's what I was trying to go through with the other image. With this image is we can't render them in order like without paying attention. So let's see, this one, triangle 1 gets added first, and then the triangle 2 gets added second. So we have this green, and then we have this 1, but so we're just gonna put this as a float 1. For some reason something's not working correct. Amento. Triangle 1 dot scale. Why are you adding the second one and not rendering the second one, dude? What's going on here? So I think I found the culprit because I'm a silly goose and it was such an easy miss, but this was that as opposed to the axis because I wasn't passing in the axis. I haven't actually tried this yet, but let's go ahead and attempt to run it and see what happens. Oh, float 3. Nope, guess we need to. Yeah, so that goes to show you what is going on here. Axis of this axis what? Scale. Yeah, what are you talking about? I know I have it, guys. Be patient. Must be separate consecutive lines. Oh. Excuse me. All right. So I guess that was easy enough. I'm getting tired. I'm ready to stop looking at the screen for a little while. I just got up and had an apple. Walked away. Came back and boom. Answer right there in the face. Cool. So now it's working. It's not working, but let's go to our basic scene. We're going to add this. This is float 0.5, and we're going to go ahead and do exactly what I did before and add 2 triangles. Get this working so I can get off. We're going to scale the first one by 0.8, and since we don't have rendering order, like I said, unfortunately, we can't. So add triangle 2. Gotta set this to triangle 2 dot scale and stop it. Change this to 0. What? Red, green. We should have a red in the background, a green in the front. One's a little bit bigger than the other, and there we go. So it's working. We're scaling. Let's scale. Next week, we'll go over the translate and the rotate of the model matrix. And then maybe we'll do a little bit of camera work. Yes, we're not going to do that this episode. I thought it'd be a good idea, but nope, not going to do it. So, thanks for watching. See you when I see it.